Okay, so an object is accelerating east to west in this video. We're just going to clarify that east is positive and west is negative. So now that we've done that, we can say that its displacement over time is going sort of like this. It's not the nicest, but it's the best I can get. Now, let me give you a mini lesson on tangent lines very quickly so you can understand these next two ones. So the thing about curves you might have learned in Algebra 2 is that they don't have constant slope. So the rate of increase at one point is not the same as at another point. So what we can do to sort of express its rate of increase is draw these tangent lines. There are lines that only intersect our curve once at this one point and have the same rate of growth as our curve at that point. So they're pretty darn unique. And so these tangent lines will increase in slope as you go up, or rather down in this case, this curve. So now, for velocity, we can basically do this because as you can see on our curve, our slope is slowly getting lower and lower. At the beginning, it was 0. Well, technically it was a little bit, but at the beginning, our slope or our velocity was 0. Here, it was moderately big, and here it was huge. So if I just delete those random strokes for a second, we can do the same thing with velocity. As you can see, the slope is decreasing over time at a constant rate. That's the unique thing about quadratics. So the velocity graph is going to show something like this. And since this is a linear graph and the slope of a linear graph is constant and acceleration is like the slope of a linear graph or the change in a linear graph, then we draw this straight line for acceleration. That's once again on the negative side because you can see we're decreasing over here. These are all just sort of flipped versions because their distance, speed, acceleration, they're all just the magnitudes of their respective things. And because we're not traveling in weird directions or anything like that, the magnitude is, well, the distance magnitude is the same as the displacement magnitude. The problem is that the direction of the displacement is not consistent with, well, distance doesn't have direction. So we just automatically convert everything to positive. There is no such thing as a negative axis. These are positive, there's no negative axis to speak of. So we basically just take the absolute value of everything that we drew. And here is it traveling west to east. Since east is our positive direction, these are basically going to look like these graphs that we have right here because it's accelerating in the positive direction, so we don't really need the negative direction. So it's just going to look like this, this, and that. And I mean, we default to positive for here. Oh, sorry. I just did that out of instinct. It moving at constant velocity, clearly. So constant velocity, the thing about constant velocity is that acceleration is 0 and velocity is constant. So it's going to kind of look like this graph from before. So if velocity is constant and velocity is the slope of distance and a regular line slope is constant, then that means distance slope is constant. Or distance is a straight line, in other words. So it's going to look something like, oh, east to west, whoopsie daisy. That's displacement as well, so I shouldn't have said distance. The velocity is negative, but it's constant, and the acceleration is 0. And basically the absolute values for this one, and there we go. An object moves with constant velocity from west to east. Once again, we can see this phenomenon here. That is west to east, I believe. So let's take west to east. And, well, it's basically the absolute values of all the three graphs we have here. So we have this one, just this one, and that one. Because we're moving west to east, not east to west. since we're moving in the opposite direction, everything gets reflected over the time axis. And obviously distance, speed, and the absolute value of acceleration are the absolute value of all the bad things that happened here. So now, graph with the constant velocity that returned to the origin, I think that's the buggy. So as you can see, that's placing the buggy right here, and it flips off the Mac screen and it goes back on its face. So that is east to west, I believe. So we can and okay. So east to west, since it's returning to the origin, it's moving at constant velocity too. So it's basically going to look like this because it goes east to west, then it goes backwards west to east. So the displacement graph is going to look sort of like an absolute value thingo. Oh, wait, 1 second. Actually, there's a little bit of flat downtime where the thing is not moving. And because of that, due to that, we have, my drawing is a little too delicate, a little too aggressive here for this delicate thing, but the velocity graph is going to look something like that. And the acceleration graph, well, it's zero for most of the time, kind of shot up and down here. And these are just the absolute values of what we saw there, which means that this is actually going to look a little weird. Actually,
DT is wrong.
DT is because of the slight negative bit here.
No, DT would be like this and this.
Oh yes, you're correct. The distance traveled over time can't decrease, so it's going to look like this instead. And speed and velocity over time is also wrong. It actually kind of looks like a staircase because of this downtime here. And speed here is going to look like the absolute value. Now, the absolute value of acceleration here, well, we're just going to set it to 0. Yes, I know, that's apparently not close enough to 0. So, we'll set it there. Okay. An object moves to west to east, basically the same problem, but with all the graphs flipped over the axis. So, it's just going to look like this, a little bit like this. Wait, no, not like that. There's a little bit at the beginning where it stays like that, and then like this, and then we just take the absolute value of everything that happened here. We take this, which is going to be the same, and we take that. I know that's not 0. This is good practice for knowing the difference between distance and displacement and velocity and speed.